I'm going to click on go live. So we are live now. Boom. Students, we are live now. Boom. ठीक है? Yes. Boom, boom, boom. Let us start. See, since all the formalities are over, polls and all these things. By the way, who are joined? Okay, JNV Malhar students have joined, and JNV Korda students have joined, and Shushri have also joined. Bhopal region, I remember in the previous class, many students were there in the Bhopal region. Many students were there in the Bhopal region. So what happened now, today? Okay, first of all, text me in the chat box that what we studied in the previous class. Text me in the chat box that what we studied in the previous class. Any one of you, please, so that we can start the class soon. And where we were. In the Bhopal region, students, where we were. You must know this thing, no? You must text me this thing. Okay. Yeah, welcome all of you, JNV Malar, JNV Core, the students. You have joined late, but no issues, still welcome. Anshika, Shushri, Suryadipti, Subhalakshmi, all of you welcome. Barsha, you always join the class. JNV, okay, so fine. Students, text me that where we have ended in the previous class. Previous class में कहाँ पे end किया था? This is lens, prism, optical instruments, numericals. So today what we'll do? Today we'll start with the lens. Okay, please reply in the chat box. Lens हो गया था? Were we on the prism? Lens was completed or not? Reply in the chat box. Otherwise, I have to see on the YouTube where up to which we have ended. Okay. Okay, I'm seeing there. Let me start the recording also here, side by side. Recording to the. Okay. So Avanti Live 13 and on the Bhopal region, let us see Avanti Live 13. We'll see where we ended. That was 22 Feb. I mean, it's Tuesday. Last class happened 12 January. It's 15 Feb. Okay, students. Okay, students. So now we'll be starting the lenses. Okay. So we have completed till what? Refraction through a simple spherical refracting surface. Now we'll start with the lenses. From the lenses, we'll start now. Completed. I have seen on the YouTube at where we ended in the previous class. Okay. So before that, let me erase some of the things there because from your previous class, the students have completed their lenses part. Okay, so I'm removing it. I thought that you people completed it already, and you haven't replied me also about this. I thought you people have completed and you haven't even replied this. Just wait, just wait. Yes. Recording is happening? No, yeah. Okay, let us begin now. Lens, prism, optical instruments, numericals. So this session will be now super energetic. Okay, this session will be, students, so much energetic now. This is not energy, it's science, by the way. So I'll complete it now. Okay, boom, lens. So today we'll start a fresh topic. No need of recall of that. A refraction you already know, students. 1,000 times you have seen that thing. Okay, prism, optical instruments is remaining. In your class, many things are remaining. Numericals we have to do connected with all this. Then at the end, finish. Ray optics, end. Okay. So after this, we'll start from the next week for your class. Today class and tomorrow's class, we need to end this chapter fast. We try to end. So next week, we will try to start. If the class happens, somehow wave optics will be started. Okay? Be focused here. Write the heading of the lens in your notebooks. What is this lens thing? So we define a lens is a transparent medium bounded by two refracting surfaces such that at least one of the refracting surfaces is curved. Remember this always, or spherical. Okay? A lens is what? Lens is a transparent medium bounded by two refracting surfaces such that at least one refracting surfaces such that at least one of the refracting surfaces is curved. What does it mean, students? I'm explaining you here. See this, it means like this. We have studied till now what? Suppose you're having one refracting surface like this. Suppose you're having, okay, all of you have joined, good. Sonalisha have joined, Dipti with Tulsi have joined, great. Okay, so you students are new here, but no issues. So now I'll explain you how to make a lens, by the way, before proceeding further. Now let us see how to make the lens first. Okay. Lens, how to make a lens, simple lens. This is what, students? Refracting surface. This is what a refracting surface. Now let me tell you how to make the lenses, okay? See, suppose this is some surface, okay? It is a refracting surface. This is refracting surface like this on your screens. Okay, this is what refractive index with N1. This is what refractive index N2 here. Okay, this is center vertex. We know of this. Okay, so we know this thing. If this is object something like this, height of the object O. Okay, so we know this formula. What was the formula? Formula was this: N2 minus N1 upon R. Suppose this is the radius of curvature defined for this. Okay, it is equals to N2 by V minus N1 by U. This is N2 minus N1 upon R. N2 by V minus N1 upon R. If you say this surface, here also, if you want to see the images, suppose this is the object distance. Image distance will be founded by this formula. Again, even for the some other curved spherical surface refraction, we want to see if this is the radius curvature defined for this. But the object is here like this, so here also we'll say this is N1, this is N2. So for here also we'll say like this. that n2 minus n1 upon r, this is equals to n2 upon v minus n1 upon u. ठीक है? Okay, students, I hope it's understood. So suppose we are connecting both of these reflecting surfaces now. If I connect both of these reflecting surfaces by doing some simplifications in these formulas, you'll get a formula for a thing which is this, and this is a lens by the way. Okay. So now I hope you get an idea how the lenses is produced. So when we merge two different curved reflecting surfaces like this one and this one, when merged together, it gives you this kind of thing which is convexo-convex lens or biconvex lens. Okay? It gives you this kind of thing that is convex lens or biconvex lens. Okay? It is also named as equiconvex lens. Equi means equal radius of curvature. Equal means equal radius of curvature, radii of curvature. That is R1 equals to R2 equals to R. Both of these lenses are here on your screens. Okay. And suppose if you merge a planar, see, we have how many types of reflecting surfaces, by the way? I want to ask from you people. Text me in the chat box. Barsha, Munarina, Subhalakshmi, Tulsi, or anyone, JNV students, Anuradha, anyone, okay? Please reply in the chat box that how many kinds of refracting surfaces till now we have studied. How many kinds of refracting surfaces till now we have studied? Any one of you? Okay, let me, okay, I'm writing here. See, focus. Focus, 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 focus. So one of the students have texted, it's good. You have replied, it's very good. So I'll say like this. You say two. No. If you focus one like this, like concave, bulged in, not polished, because if it is polished, it will be mirror. Next, like this. Oh, I have made it somewhat, irregular shaped. So next, like this. This is what? Convex. Bulged out. This is what? Bulged in. It is concave. And this is the number one. This is number two. One more surface is remaining. It means it's planar. Because we have seen, no, like this actually we have seen, if the fish was inside. So this boundary which is separating two mediums, water and the air, it is what basically? It's a boundary separating two mediums, no. It's a planar refracting surface, you can call like this. So this is the third one. So by mixing 1, 2, 3 or 3, 2, 1 or 1, 2, 3, 2, 2, 1, 3, 2, anyhow, by mixing these three surfaces, reflecting surfaces together, we can remember number of combinations of the lenses. How? If you mix this with the same, you'll get this. Okay. If you mix a planar with a bulged in, you'll get a plano-convex lens. If you mix the bulged out with a planar, you'll get a concave convex. Okay, no, this is not a planar, but if you copy this copy paste, so you will get a crescent moon kind of thing like this. Just concave or convex lens. If you see this is biconcave. It means this bulged out in this direction, this bulged out in this direction, join them. Remember always, because all the lenses are, by the way, students, thin lenses. याद रखना इसको. All these lenses are basically what kind of lenses? These are thin lenses. कैसा lens है students? These are thin lenses. Okay, let me see. Is the recording going on? Yes. So similarly, see, one more thing to remember is this. Biconcave. Remember this thing. What's the difference between biconcave and equiconcave lens? See, biconcave is like this. Biconcave means the radii of curvature of both of that individual reflecting surfaces. Suppose this is the first surface. So connected radii of curvature for this surface is R1. If this is R2, this is the second refracting surface. So connected radius of curvature for this is R2. If these are different on both the side, radii of curvatures, I mean curved surfaces, the curvature is basically different. So we'll say it is biconcave. It depends bulged out or bulged in. Bulged, it's like for convex is like this. For this, it's like, see if you call on this side, it's bulged in, but you'll treat it concave. Concave matlab ka is basically it's this. Okay, you're using like this. It's convex. And again, you can name it as equiconvex when both of the radii of curvatures are same. That is R1 equals to R2 equals to R. Okay. In convex, if you see, R1 is not equals to R2. But when it is equals to R1 equals to R2 equals to R, this is equiconvex. Okay, clear? Is this thing clear, students? Okay. Since we have added all this planar with the convex thing, so we'll add with the concave surface also. So we'll add with the concave surface also. Okay. So I'll say like this: planar plus concave. This will give me planar concave lens. This will give me convex concave lens. So through this, we'll get the combination of lenses. See, students, I am seeing some students, they are not responding properly. Can one of you text me in the chat box? We have to start with the lens only, no? I mean, is it okay to start with the lens or you want me to start from the prism? What do you say? Starting with the lens is fine, I think so. What do you say, students? Starting with the lens is fine, isn't it? You're not responding, no. So that it makes me feel, you know, what is happening. Reply here. Okay, one of the students have replied. Thank you so much. So GNV prism. Okay, raise all your hand, like all of your students raise your hand. From where you want to start, it's up to your demand, no issue. If you don't want to repeat the things, let it be. So where you want to start? From the prism? Directly from the prism, GNV core the student says it's prism. I want everyone views. I want all of you views, okay? So from where you want me to start? Please reply. Prism or lens only? So it's up to you. I can start with the lens. I can directly start with the prism, because if you feel that thing, if you feel this thing that you can study the lens yourself, okay? Lens topic yourself. So I can start with the prism. Reply here. Give the votes. Prism, how many students? Prism, how many students? Reply. Prism, how many students? So if you're not, okay. JNV Khorda, raise the hand. Kisal, start directly with the prism. Please, all of you reply. If there are some replies, I will start with the prism. Otherwise, I'll be continuing like this. One of you reply. One more reply I want. Just Tulsi reply, Dipti reply, JNV Malar, Sonalisha, Shushri, any one of you reply fast. JNV, all of you have to reply this thing. I need to start from the prism or this. Start, like, continue with the lens. No issues. Okay. Okay, I'm starting with the prism then. Okay. I'm starting with the prism. If it's fine then, okay. Just wait. Just wait, it's loading here. Okay, Dipti says start with the prism. Cool, okay. So now I will surely start with the prism, okay? Just wait, it's loading here. Okay. So write the heading prism and natural phenomenon due to sunlight, okay? Write these things, and these are the contents of today's topic. So first we'll go through the refraction of from prism, and then dispersion of light by prism, okay? Then rainbow formation, and at the end we'll see scattering of light. Write all these 4 topics. So after you have written, text me in the chat box so we can start it. Okay. Write these 4 topics and then text reply in the chat box so we can start these things fast without wasting time. Time, students, is very important. It's so precious. You can't, we can't get the time back. The once you have wasted it, I mean, if you have consumed it properly, it's so good. Good memory. See, लिख लिया, contents लिख लिया. Refraction from the prism, dispersion, rainbow formation, scattering of light. Refraction through the prism is what? See, this is a prism here. It's on your screen. See how you make a prism. Suppose you take two, see, okay, first let us see difference between the slab and the prism here, okay? Suppose you are having a slab, just watch on the screens. See, if you take a glass slab like this is what a glass slab, okay? And the ray is going like this. It's passing from one side, entering like this and coming outside. This is a ray passing from a glass slab, okay? Surrounding medium is what? It's air or vacuum like this. This is a surrounding medium. And inside it is having the refractive index as 3/2, 1.5. Okay. If suppose I turn this slab in a horizontal direction and inside it is having refractive index 3/2, this is a normal here. Okay. And if the ray is passing like this down, this is what? Incidence angle. You know this thing, when the ray passes from a rarer medium to a denser medium, it turns towards the normal like this. So again, when it will pass from a denser to a rarer medium, it will bend away like this. Okay? So there is a little shifting in the incident ray and the emergent ray. So what is the little shifting? We know we have studied this, and this is some T quantity. Okay. See, these are the cases of the slab when the ray passes from the first case. When the ray is here in the first case, and when the ray is here in the second case. Okay. But if we consider this prism, if the ray is passing by a prism like this, what happens? It shows the deviation. Okay, I'm drawing a simple diagram here. Just focus. It is going like this. It's going inside. So there is the first surface is this. Remember, this is the first surface. The two surfaces are like this. If the ray is passing from this surface, it will turn itself when it passes from external to internal. External का क्या मतलब होता है? External का मतलब ये होता है it's rarer medium. Internal मतलब it's denser medium. So when the ray passes from a rarer medium to a denser medium like this, okay, we know this thing, it bends towards the normal. So if I draw a normal here, this is what? This is what? Normal like this. So if this angle is the angle of incidence, this angle will be what? It's angle of reflection. So I will call, this thing, since it's bending towards the normal, I'll say angle of I will be greater than the angle of R, that is refraction angle. Okay. And you can see this ray has turned for the first time when it passes from the external to internal on this number surface. Now when it is passing via from inside to outside, I mean clicked on the second number surface, it will deviate again and it will come out like this. So this will be normal now. This will be what? Normal now. Okay. And this angle is now the angle of incidence for this, and now it's coming out. Remember this thing. When the ray is coming from a denser medium to a rarer medium, it bends away from the normal. So now it will bend away from the normal like this. And this angle is now emergent angle. And the ray is named as emergent ray. And since we know this thing, when the ray passes from a denser medium to a rarer medium, it bends away from the normal. Okay? So we'll say here that E is greater than I here. Okay? So E is greater than I here. Finish? Because it's a rarer medium. These are all the things what is happening when the ray is passing by the prism. As compared to the slab on the left hand side, when the ray is passing via the slab, when it is normal, it will pass normal. Okay. When it is passing by the slab is like this. It's passing by the slab with some angle with the normal. It will give you a little shift. See, initially it's incident. Finally, it's again the same direction. Direction means the parallelism law is followed. These both the rays, incident ray and the emergent rays are parallel, but they are laterally shifted. If it's coming like this, it will be laterally shift. It's coming like this, it will be lateral shift. Okay, finish. But special case of prism is what? That when the light ray passes by the prism, it deviates 2 times like this. Shown. Like this, like this, like this. Like this, it's coming inside. Like this. So there's a deviation. And now, if you focus on the incident direction, students, this is the incident direction. This is incident direction. And emergent ray direction, if I focus, blue color you want, emergent ray direction is this. So there is a very beautiful angle between these two. There is an angle like this. This angle is angle of deviation, about which we are now going to study in the next slide. First of all, reply in the chat box. Is this thing clear or not? Reply this thing in the chat box, students. Is this thing clear or not? Chat box में reply करो students. Is this thing clear? Okay, finish. Now we're going to talk about the angle of prism. Sorry, angle of deviation. So suppose I'm drawing in front of you this thing, which is see. This is a prism. Remember, ये जो ऊपर वाला angle होता है, this angle is known as apex angle, or this is known as angle of prism. This angle on the top is known as apex angle or angle of prism. Okay? And when the incident ray is passing on one side like this, if I draw a normal to it, this is the normal. Angle of incidence is I here. Okay? So when this incident ray will pass like this from one side to internal of the prism, see this, you can see yourself how it's bending. Okay? So now the angle made by this incident ray in the prism with the normal to this side will be what? It will be R1. Okay, and it follows the laws of reflection, it follows the laws of refraction, which I have already told. Remember, it's what? Refraction. I mean, following that law, that when the ray is passing from the external medium to internal medium, say via a rarer to a denser medium, so you'll get what? It's bending towards the normal. Okay, and vice versa. It means when it's passing from a denser to a rarer medium, it will bend away from the normal. So one thing you have to remember is this: when the ray is in the rarer medium, it will bend away from the normal. Okay, clear? So if you see here, see what is happening when the ray is coming out like this. So this emergent angle is this, which the emergent ray makes with the normal. Okay, this is the emergent angle. See this. This is the emergent ray. This is what? This is emergent angle. Okay? And you can see this thing, this emergent angle is greater than this R2. Okay? And the ray is passing inside like this. Okay? So if you want to derive the angle of deviation, so how we must derive? Okay, so let us see. First of all, I've already told you what's the angle of deviation. I'm writing a definition here, so see carefully. That angle of deviation is defined as angle by which the incident ray is turned from its like initial direction. Okay, or you can say like this: the angle which the emergent ray makes with the incident ray direction. Okay, so the simplest definition is this: angle which the emergent ray, you can note this thing in your notes. Okay, angle which the emergent ray, angle which the emergent ray makes with incident ray direction. Incident ray direction. Okay, is it clear? So now we'll derive the deviation angle. See delta, it's the symbol used for deviation angle is delta here. Okay, now we'll see that this delta is equals to what values. Okay, it can be equals to I, E, A, or by some arithmetic of these three things, I, A, or E, or R1, R2 maybe, I don't. See, don't go into the derivation now. Just remember the formula. Derivation will be given to you on the PDF. So try to understand. If you get it, it's okay. Otherwise, we'll see. We'll in the next class, we'll explain. Okay. So by using some geometrical laws, you'll get, remember the first thing you have to remember is this. This also I'm marking with a star point. Remember always, angle of prism is equals to this R1, R2 angles. What are these? These are basically angle which the incident ray makes after the refraction via first surface. Okay. And the angle which this again the incident ray makes inside the prism when it is going to be reflected by the second surface, or when it is passing from the second surface. Then applying some geometrical laws, ultimately you will get this thing. This is del. Del means angle of deviation. So it is I. I is what? Incident ray angle. This is incident ray angle. E is what? It's emergent ray angle. A is what? It's angle of prism. This is known as angle of prism, or apex angle. Somewhere you'll find it as apex angle. Okay. So now see, this is the formula we have derived. We have to remember this formula because questions will be asked based on this formula. This you will use for applications. Okay. See, now there's a graph between variation of the angle of deviation with the angle of incidence. Again, if the ray is passing like this, as we know, or it's passing from that direction, similar it is. I mean, there are not a lot of changes. So in both the cases, let me show you the first slide. It's better. Okay. See, this is the incident ray direction. Okay, I'm using the same color, yellow. It's the incident ray direction like this, and this is the emergent ray direction. So if you see the angle between both of these, this is del angle, that is angle of deviation. Okay. Now this graph is giving us a very like interesting pattern that if I highlight this, okay, there's a point. So see, you can see from the graph on the y-axis, it is angle of deviation, that is 50 degree. Okay, if you match with the graph like this, so we are having two x coordinates here, x1, x2. Okay, na? We're having what? x1, x2, two coordinates, and on the y-axis we are having one angle of deviation. So for a particular angle of deviation, we are having two values, x1 value and x2 value. Okay, for a particular angle of deviation, we are having two values, x1 and x2. And x1, x2 are what basically? These are particular angle of incidence 1 and next the particular angle of incidence 2. So we can conclude from this graph that is for two different values of angle of incidence, we are having a single value of angle of deviation. Okay. So for the two different values of angle of incidence, we are having the same angle of deviation. Okay, this is one conclusion, first point. Second conclusion is this. Second point which we can conclude from this is this, that this minima This is what the well structure. This, this graph looks like a well. So this minima, this point, if you focus, you can see on the y-axis or on the x-axis that there is some angle of incidence between 40 to 60 degree, and corresponding to this on the y-axis, there is a point which is 40 degree. Okay, I'll say, see, it is not for all. I mean, the first concluded point is not for all the values of incidence angle. Okay, so there will be one angle for which angle of deviation will be single and it's minimum. Okay, so such angle of incidence is given here equals to the emergent angle only, and for such the angle of deviation will be minimum. This we can conclude from the graph. Is it fine? So we can say like this. So for I equals to E, we'll get an angle of deviation. See, we have to do some more substitutions here. Then only we'll get the minimum angle of deviation. But I will say this: for I equals to E, we are getting an angle of deviation which is the minimum here. Okay, this is what this is minimum angle of deviation. So now let us see. Okay, now we are going to derive the minimum angle of deviation, and we are going to observe this thing. What happens when the ray is entering in a prism, and if it's following the law of, I mean, the angle which it is going to make, the deviation angle is minimum. So what will be the internal ray direction in the prism? Okay, how the ray will show its nature in the prism inside. So you see here, see, when the angle of deviation is minimum, so if I mark it back, if I extend it back like this angle is what? Delta. This is angle of deviation. Angle of deviation like this. Okay? Delta is what? Angle of deviation. When this delta will be minimum, no. So remember this thing, that the ray inside is parallel to the base. Okay? See, we have seen, unlike like this prism, when the ray is entering like this, it's going like this, it's going like this. So internally, the rays direction is not parallel to the base, it is shifted with some angle. Okay, but if we see here the ray is parallel to the base. That is what? It is parallel to the base. Okay, fine. So now let us start the derivation of the minimum angle of deviation. Now let us see the derivation of the minimum angle of deviation. So when I is equals to E, the refracted ray inside the prism becomes parallel to the base. One thing is clear. Also, you will know able to know this thing by geometry, that R1, R2, R. See, you people have to remember those are the applications. Okay, don't go for the derivation. Derivation is for conceptual clarity, a little bit of the overview. So you can, if you forgot somewhat of the values in the formula, some missing, so you can guess back, recall, and you can again derive fast. Somewhat, understand this thing. Because I also have an experience. There was some question in kinematics, and during my times. Okay, I mean my times. I mean when I was giving the exam of some test, so there the question came from equation of trajectory. It is what? Y equals to x sin theta 1 minus half gx square upon 2u square cos square theta. It's also having one more simple format, 1 minus x upon r, like this range. At that time, I forgot this formula in the exam, and it was that question was holding 4 or 5 marks. So I derived somehow because I know the overview idea. So I just tried to utilize that fade idea kind of, and I got the formula in the exam, and I got the marks. So derivation, just keep in mind upper upper se, from top level. Okay, don't go inside it, from interface above. Don't go inside it. Okay, remember the formula always. So if you do use these laws, we know this thing, angle of deviation. We already know this thing, that angle of deviation is given by this formula. Okay. If you want to make this del as minimum. So what do you need to do? Put this values. I equals to E. Put R1, R2 equals to R. Okay, so you'll get angle of deviation is this 2I minus A. Okay, so now you can do some simplification of this equation. So if I do it, I'll get the value as this. because see, A will go, dm plus A upon 2 is I. So for such an angle of incidence, we'll get the angle here is minimum deviation. Okay, if you're given a minimum angle of deviation value, so you can use this formula to find the angle of incidence. Okay, that for such angle of incidence, and the angle of deviation will be a minimum. I mean, the incident ray and the emergent ray which is coming out, the turn, remember this, the turn in the incident ray. Nah, okay, I'm removing this virtual background. Virtual matlab, hold on. Let us use none. Now see, suppose this is the prism. Prism, how I show you with my fingers. Okay, leave. This is the prism. Prism. Ray is coming like this. It's turning and coming out like this. So emergent ray. Okay, see your video tab. It will be good. Yeah. Suppose prism is there. Okay. So ray is coming like this. It's going outside like this. So you can see the turn. I'm showing the slow motion. Turn is this. So this angle of turn with the incident ray direction, this, see this, incident ray, turning, emergent ray outside. So this much turn from the incident ray direction is angle of deviation. If you want to keep this minimum, internal ray, I mean the incident ray when passing after first reflection from the first surface and goes inside must be parallel to the base. So this is the formula for that incidence angle. Okay? Now if you do some more changes here, we know this thing angle of prism is equals to what? R1 plus R2. Here you will see when this is following this law, you will also get this R1 is equals to R2 here. For minimum angle of deviation, for del equals to dm, minimum angle of deviation, this will be followed here. Okay? And remember, internal angle is the sum of the two external angles here. Angle of prism is here equals to sum of the two. Internal angle is equal to sum of the two external angles here, R1 and R2. Okay? R is here equals to what? Angle of prism by 2. We got from this formula. Now we'll substitute it back again. And using the Snell's law, I'm fastly going towards that. You'll get the final answer is this. This, students, you have to remember it's a 5-star rating, students. I'm giving it a 5-star rating. Remember this formula. We'll solve a question and then I'll ask from you what to do then. End the class or you want to see the rainbow dispersion. Few students have texted me something. Okay, good. See now, if you focus here, this formula, students, gives you delta angle of deviation, which is basically the minimum angle of deviation. The formula is this: write the refractive index of the material of the glass if the glass is kept in the air. Write it like this, minus A. Write the refractive index of the material of the glass with respect to the air, with respect to the surrounding medium, if surrounding medium is not air. Because if mu(s) is air, it is 1. We'll say mu of the glass upon mu of the surrounding medium minus 1 angle of prism. I remember in the questions, angle of prism for minimum angle deviation, more probably, you know, I mean, you'll find it like very small angles. Okay? So ready for the concept test? Question is this: prism is given to you, surrounding medium is air, refractive index 1, refractive index 1, angle of prism is 4 degree, and this is refractive index. Okay? Of the glass material. Angle of prism is 4 degree. They're asking from you here to find the minimum angle of deviation formula. You will know. I will not write the formula. Text me the answer in the chat box. Concept test it is. Whatever you understood, apply it here. What is the minimum angle of deviation formula? Now only we have seen recently. See this 5-star rated formula. 5-star rated formula and explained on the right hand side by 2 symbols. This is the formula. Seen? 10 seconds over. Okay. Very clear? Finally, now apply this on the concept. What do you think? What is the answer? What will be the minimum deviation answer of this question? All of you. It's very easy, students. Very good. JNV Khorda students have given the answer. Excellent, students. Very good. Very good. Too good. Okay, you got the right answer. What about Dipti, Monarni? What about you? See, we got from this the angle of deviation which we are getting as mu minus 1 angle of prism. Mu is what? 3 by 2 minus 1. Angle of prism is 4 degree. So 3 by 2 minus 1 is half, multiplied by 4 degree gives you 2 degree as the answer. Okay, and this is known as angle of prism. Sorry, angle of minimum deviation. Answer is fine. I'll show you the solution. This is a printed solution. Answer is 2 degree. Confirmed. Okay. Now, students, it's time to end the class. So I'm going to end it. In the next class, we'll see some more numericals. Okay, and we'll see optical instruments. Finish tomorrow. Okay, and we'll numericals, and then from the next week we'll start the wave optics. So students, please participate in this NPS. All of you, please participate in the NPS. And if you're having any doubt, if you're facing any doubt, students, please reply on this. Okay, if you feel that if you are at the home, you can use your phones then, na? So you can reply here on the WhatsApp. I mean, we can make a group for the doubts, an extra group based on ray optics. And if you're having any other doubts, 24/7, you can ask. You can text on the chat box. I mean, here also now, and you're having the number here. Okay, so participate in this NPS so that we can end the class. Participate in this NPS so we can end the class, students, fast. Okay, bye, Jinvi. For the students, how? Okay, bye. Hai na? So I'll be now, ending this live stream. So YouTube students, bye bye, everyone. Take care. Study well. We'll meet tomorrow's next class. Okay. And for reference, use HCV materials and a motion sheet I will upload in the notes. Motion exercise questions